Okay, hello everybody and welcome to this video on matrix pricing. This is just an extension of some of the other videos or topics we've been covering within this initial pricing batch of recordings. We're going to deal with pricing bonds when you have to estimate the yield to maturity by looking at other more frequently traded instruments. So what's all this about? Well, the issue in the bond market is that most bonds are not actively traded. So they are relatively illiquid instruments. Obviously, there are exceptions. For example, government bonds are typically quite frequently traded, especially on the run securities. Those are the ones that have been issued relatively recently. So, however, especially most corporate bonds are going to be relatively illiquid, so it's relatively difficult to obtain up-to-date prices. And if you don't know what the price of a bond is, you can't really know. You won't really know what its yield to maturity is, this is also important for issuing new securities. If you don't know the yield to maturity required by investors in existing bonds, it's difficult to get the parameters of a new bond right to satisfy investor expectations. So the solution to that problem is quite simple. You identify more frequently traded bonds, identify more frequently traded instruments. There should be some at least, but they should have, so with similar parameters like similar time to maturity, similar coupon rates, or similar coupon structures, fixed or variable. Similar credit quality as well. They don't have to be from the same issuer, but at least some things need to be similar. And for those more frequently traded instruments, calculate their respective yields to maturity. Now, if you have more than one bond, which is actually preferable, more than one bond for each sort of time to maturity bucket, time to maturity slot, then calculate the average. Calculate average yields to maturity for each maturity. So here, calculate yield to maturity for each bond, but then try to summarize things. Calculate average yield to maturity for each maturity, sort of at least a maturity bucket, like 5 years, 6 years, thereabouts, plus or minus a couple of months. And finally, once you've done this, and we'll practice this in a question in just a moment, use linear interpolation. Now, interpolation, it sounds worse than it is, to estimate the YTM, the yield to maturity, on the bond we're analyzing, on the illiquid, or maybe the new bond that we're about to issue. And if you know its yield to maturity, if you can estimate its yield to maturity, you can estimate also its price. Okay, that's the logic of it. Let's do a question on this, an exam-style question, which are very much sort of based on what's in your book. It's got different data, but it's quite similar. An analyst is attempting to price an illiquid 3.5% annual coupon paying bond with 5 years to maturity. Now, I've made this annual coupon paying just to keep things relatively simple, because we're going to have to compute yields to maturity with 5 years left to maturity. She identifies, that's the analyst, 2 frequently trading bonds with similar credit quality. So we've got bond at X and Y acting as sort of comparable bonds. They've got respectively 4 and 7 years to maturity. They pay different coupons, and they've got their own individual prices. Now, if the analyst uses the matrix pricing approach, the estimated price of the illiquid bond per 100 of par value is closest to, and we've got 3 options as always. So, let's take this step by step. First of all, we've identified some more frequently traded trading securities that are comparable. Good. Now, for each of them, we're going to calculate the YTM, the yield to maturity. But because we've only got one representative for each maturity sort of bucket, we've got a bond for 4 years with 4 years to maturity and 7 years to maturity. We're not giving more than one representative of each category. There will be no averaging because we only have one representative. So that this step will in fact be omitted, and we'll jump straight from here to the linear interpolation bit. Okay, so we've got bond X and bond Y. Let's use the data over here to do the relevant computations. Of course, I'm going to utilize my calculator to do this, to perform the relevant computations. So please, make use of the time value of money worksheet. I'm just looking hectically for my calculator. Here it is. Right, I'm going to fire up the calculator and start off with bond X down here. Let's look at the parameters. The parameters are 4 years left to maturity, 3.2% coupon. It's paid annually. Sometimes in the curriculum, but also probably in the exam, you may find S/A. That's going to mean semi-annual payment frequency, which means you have to double up on the ends and equate everything to a per period, so per 6-month level. Here I'm trying to make things relatively simple and just sticking to annual coupons, just for the sake of practice here. However, do have a look at some of the questions in your books and in your end of chapter problems to see the alternative approaches here. So bond X, I'm going to make N equal to 4. So let's do this straight away on the calculator. 4 followed by N. Then the coupon is 3.2. So PMT is going to be 3.2, effectively 3.2 followed by PMT. Of course, I did clear the time value of money worksheet beforehand. Didn't see me do that. I didn't have my calculator recording yet at that point. What else? I'm going to make FV, future value 100, and price, so PV equal to negative 99.2. So 99.2, stick a minus in front, PV, and now we are ready to compute. So that's CPT I over Y. Okay, as you can see, it's displaying my calculator is displaying a result of 3.417 over here. That's for the first bond, that's bond X. Now let's do the same thing for bond Y. This time a very different time to maturity, not just, more years, 7. So let me write out the data. N equals 7. PMT in this case is going to be the annual coupon of 4.1. Of course, if we were told the coupons were semi-annual, you'd have to take that coupon, divide by 2, but double the number of periods for N. FV and PV would not be touched, but the result would be an I over Y, a yield that you'd have to double up to get it up to an annual basis. Okay, what else? We've got a price of 100.9. So first FV equals 100, but then PV equals negative 100.9. Okay, let's clear the time value of money worksheet and work with this data again. 7 for N, 4.1 for PMT, 100 for FV, and 100.9 negative for PV. And again, let's compute I over Y. Okay, my calculator is displaying 3.950. Now, we've calculated the yields to maturity for the two different bonds with different maturities. I don't have any, as I said, don't have any other representatives of bonds belonging to those maturity spectrums to calculate averages. But let's now use linear interpolation. The thing is, the bond in question, the bond we're supposed to evaluate, has 5 years left to maturity. So it's not 4, it's not 7, it's somewhere in between. And the idea behind this is to say, if you've got a bond that has 4 years to maturity and a yield of 3.417%, that's for the 4-year bond, and you've got another bond with 7 years to maturity, whose yield, which we just computed, is 3.950, then surely we can at least estimate that the yield on the 5-year bond, 5 years is, I guess, here, can be derived from the two that we already know. It's going to be, somewhere here. If it was a 6-year bond, it would be there. It's not going to be as high as 3.95, it's not going to be as low as 3.417, but somewhere along the way, and it's a linear function. Now, from 4 to 7 years, that's a stretch of 3 years, and we only need a stretch of 1 year out of those 3. So, I guess I like to draw this graphically, but the thing is, the YTM, the yield to maturity on the 5-year bond, is simply going to equal this base, 3.417%, that's the yield on the 4-year instrument, plus 1/3, 1 year out of 3, of this difference, the difference between 3.950 and 3.417%. Okay. Now the 1/3, just be aware of the fact where that comes from, because when your curriculum talks about this, they kind of make this a little bit more explicit. They kind of say, "Ooh, this is going to be the difference between 5 minus 4, that's the distance over here, over 7 minus 4, so that's that distance," which ultimately gives you 1/3 anyway, right? It's a more sort of precise way of writing it, I guess. Same result. And let's now see what the result is. Get the calculator again into our hands. So 3.417 plus, open bracket, did I need to open that bracket? No, so close it. Once again, 3.417 plus 1/3 multiplied, and you can see it's already showing me this is 1/3, by what's in my brackets here, 3.95 minus 3.417, close the bracket, equals, okay, the yield is going to be 3.595% if I round it to the third place after the decimal point. And now, obviously, this is not the answer yet. What I've done is I've estimated the yield to maturity on the illiquid new bond. That's going to have 5 years to maturity. But now I need to use this estimate to actually get the price of the bond, because we were asked for an estimate price of the bond. And I did say before, once you have the yield, you can actually think about the pricing. So this bond is supposed to have 5 years to maturity. It's paying a 3.5% annual coupon, annual coupon, not semi-annual, and that's pretty much all I need. So on the calculator, I'm going to have n equal to 5, PMT equal to 3.5. My I over Y is going to be what I've just computed, 3.595. That's the reason why we did it. That's the reason we did it. We're going to have an FV of 100, and obviously we're going to compute PV. Now, clear the time value of money worksheet first. 5 for N, 3.5 for PMT, 3.595 for I over Y. You can see the yield is going to be slightly higher than the coupon, so the bond will be priced at a discount, slight discount, I think. Right, I got this one wrong, didn't I? 3.595 I over Y, that's better. 100 for FV and compute PV. Right, 99.57. Let's see if there is an answer that corresponds to this. Indeed, there is. That's answer B. So, this is a pretty simple approach. When I studied the questions, or when I looked at the questions in the curriculum, they either asked you to do this, or they already gave you the yield to maturities, and then you had to do the interpolation. And when they give you the yield to maturities, what I've noticed is, because you have one less thing to calculate, you don't have to calculate the YTM. They'll typically give you 2 bonds per each maturity, so at least you have to do some averaging, but it's still, the same principle. So go and have a look at the questions at the end of the chapter, or in the knowledge check examples, and hopefully this should be no problem at all.